Hi everybody, we are moving on to learning target 5 in chapter 1, which is about area and perimeter on a coordinate grid. So if I were to give you a shape like this and ask you to find the area of it, it wouldn't be too bad. This is a trapezoid. You might remember the trapezoid formula. You aren't given that one. You are given the formula for the area of a triangle and the area of a rectangle. And I'm assuming most of us can see that there's a triangle and a rectangle built into that. So if we were to just draw a dotted line down there, we could see those two shapes. And then I just need to essentially plug and chug. So I have 1/2 base times height because that's the area formula of a triangle. And then I have base times height because that's the area formula of a rectangle. So if I just substitute the values in, now I have a base of 2 and a height of 6 and a base of 3 and a height of 6. I just calculate and boom, I get 6 and 18. Add them together and the answer would be 24 square units. So anytime you have a shape like this that you can cut into two two easier shapes, you should do that. And you want to make sure that you can always count a horizontal base and a horizontal height. Otherwise, you can't actually count them. Which brings us to this shape. So it looks like I'm showing you some stuff already here, and that's fine. When you have a shape like this, you can't really break it into other ones. Like you could maybe break it into a triangle here, but they're not nice ones that you can count the base and height of. So this is another method called the box method. What the box method is you make a box around the shape that hits all or almost all of the vertices, which are the points, and then you calculate the area of that box. So I made a rectangle with a base of 5 and a height of 7. So that currently has a area of 35. Now, essentially what the box method is you're just cutting pieces off. So like think about if you had a piece of some scissors and you just cut along that line, right? You'd be cutting that piece of paper off. So you're cutting this triangle off, you're going to cut this triangle off, you're going to cut that triangle off and that triangle off. So all of this red is coming off. So you have all of these areas of triangles that you're going to subtract from the box. And then don't forget about the square that was up here. That won't always happen, but it did this time. So that's a square unit because it's a 1 by 1 square. So I'm just going to calculate the area of all 4 of these triangles. So if I start with the triangle up here, that has a base of 4, height of 1. So if I plug that into my area formula, I get 2. Okay, again, I already have this square unit. Now if I move down here, that's a base of 1, a height of 4, whichever way you want to say it. So that's also an area of 2. Moving down here, that's a base of 4, height of 2. So that's an area of 4 because, again, it's 1/2 base times height for a triangle. And then this last triangle is a base of 1. And you got to be careful when you count. It kind of looks like it only goes to here, but make sure you pay attention. It does, in fact, go all the way up to point A. So that is a height of 7 and a base of 1. So that's 3.5. You're going to add all of those together, and 2, 2, 4, and 3.5 are 12.5 because 2, 2, and 4 is 8, and then, that should be 11.5. Sometimes I add wrong. It's fine. So this should be 11.5, and then from there, you're going to subtract, so this would be 23.5. So you just subtract all those pieces off of the whole big box. All right, the last one is calculating perimeter. Now, the perimeter is the distance around a shape. So it's not how much space it takes up, but it's the distance around it. So if you were building a fence, it's the fence. It's not the part that you're partitioning off with the fence. It's the outside. Okay. So notice I use the word distance. You can absolutely use your distance formula and calculate the perimeter. You'd have to find the distance of each side. If I started by finding the distance of AB, I would start with y minus y, so -1 minus 3, and x minus x, -4 minus 2, just using the coordinates they gave me. I would then go through the formula, get -4 and -6, square both, make sure that those are positive numbers. We talked about that. And then the square root of 52 would be my answer. You can do that for each side if you want to. I would like to remind you that you also have triangles that you can deal with their slope. So remember, if you make a right triangle, you can use Pythagorean theorem. It's the exact same thing as distance formula. It just looks different. And to some people, it's easier. So I have a side of 1, a side of 5, and I'm looking for the hypotenuse. So 1 squared plus 5 squared equals c squared, and I get radical 26. Same thing on the bottom. I can make another right triangle and have a side of 1 and a side of 7. Use Pythagorean theorem, and I get the square root of 50. The only thing you have to remember here is you're calculating the perimeter. So you would have to add those 3 values at the end. So this plus this plus this. If I asked for an exact value, you would simplify the radicals, but you wouldn't try to add them together unless they were like terms. More than likely, I'm not going to ask you to do that, and I'm going to ask it to like the nearest hundredth or nearest tenth, in which case you would just grab a calculator, type these all in, and round appropriately. That is it. I hope you have a wonderful day, and I will see you all in class.